Pull out your phone right now and type anything into ChatGPT. A question, a sentence, a random thought. Within 2 or 3 seconds, you get back a fully formed, coherent, human-sounding response. It knows context. It understands nuance. It can write code, explain surgery, argue philosophy, sometimes all in the same conversation. And most people who use it every single day have absolutely no idea how it does that. Not even close. And that's not their fault. Because the way the tech industry explains AI is either so dumbed down it's useless, or so technical it's completely inaccessible. Nobody is meeting people in the middle. So that's exactly what we're doing today. By the end of this video, you are going to understand how a large language model actually works. Not the marketing version, not the PhD version, the real version. And once you understand it, the way you think about AI, your job, and the next 10 years of technology is going to fundamentally shift. Here's the scale of what we're talking about. GPT-4, the model behind ChatGPT, was trained on roughly 1 trillion words of text. 1 trillion. That's essentially the entire public internet, a significant chunk of every book ever digitized, academic papers, forums, code repositories, news archives, all of it consumed and processed by a single system. Google's Gemini Ultra was trained on even more. Meta's Llama models, Anthropic's Claude, Mistral, every major AI lab on the planet is in a race to feed these systems more data, more compute, and more parameters than their competitors. The money being spent on this is genuinely hard to comprehend. A single training run for a frontier model can cost over $100 million in compute alone. Microsoft, Google, Amazon, and Meta have collectively committed hundreds of billions of dollars to AI infrastructure over the next 5 years. And yet most people, when asked how these models actually work, say something like, oh, it just searches the internet, right? Or it's just autocomplete, isn't it? Both of those answers are wrong. And the real answer is far more interesting. So here's what's actually happening. A large language model is not a search engine. It does not look anything up when you talk to it. It has no internet connection during a conversation unless it's been specifically given a tool to search. What it has instead is something much stranger and more powerful. It has compressed an almost incomprehensible amount of human knowledge into a web of mathematical relationships. And when you ask it a question, it navigates that web to generate the most statistically coherent and contextually appropriate response possible. One word, or technically one token, at a time. Let's break that down, because that's where it gets genuinely fascinating. During training, the model reads through all of that text and does one thing over and over again, billions of times. It looks at a sequence of words, tries to predict what word comes next, checks if it was right, and adjusts its internal settings, called weights, based on whether it got it wrong. That's it. That is the core of the training loop. Predict the next word. Check the answer. Adjust. Predict again. Adjust again. Do that billions of times across trillions of words. What comes out the other side is a system with hundreds of billions of these internal weight settings, a neural network that has essentially learned the deep structure of human language and human knowledge simultaneously. It didn't memorize the text, it learned the patterns underneath the text, the relationships between concepts, the way ideas connect, the logic of how arguments are built, the rhythm of how stories are told. All of that gets encoded, not as facts in a database, but as patterns in math. This is why it can do things it was never explicitly taught to do. Nobody sat down and wrote rules for how to write a cover letter, or debug Python code, or explain quantum physics to a 10-year-old. The model figured out how to do those things because doing them well is consistent with the patterns it learned from human language at massive scale. That emergent capability, intelligence appearing from pattern recognition alone, is the thing that genuinely surprised even the researchers who built these systems. Now here is where the real-world implications kick in, and why this matters to you personally. Because honestly, Understanding this architecture explains both what these models are incredible at and exactly where they fall apart. They are extraordinary at tasks that live inside the distribution of human language: writing, summarizing, reasoning through problems, generating code, translating ideas across formats. But they struggle with tasks that require real-world grounding, like, precise math done reliably, verifying facts against current reality, or anything requiring true understanding of physical cause and effect. When a model confidently tells you something that is completely wrong, that's not a bug in the traditional sense. It's actually the system doing exactly what it was designed to do, generating the most statistically plausible next token without any internal alarm that says, wait, check this against reality first. That mechanism doesn't exist natively. It has to be engineered in separately, through tools, through retrieval systems, through reinforcement learning from human feedback. The base model just predicts. Everything else is layered on top. So here is what this means for how you should be operating right now. Use these tools for what they are genuinely built for: generating, drafting, restructuring, explaining, summarizing, brainstorming. Treat them as the most capable thought partner you have ever had access to for language-based work. But keep your critical thinking fully engaged. Verify anything factual that matters. Never outsource judgment on high-stakes decisions to a system that cannot actually know whether what it's saying is true, only whether it sounds right. The people who are going to win the next decade are not the ones who blindly trust AI or the ones who blindly reject it. They're the ones who understand it clearly enough to know exactly when to lean on it and when to push back. You now understand something that most people using these tools every day do not. The model isn't thinking. It's pattern matching at a scale no human brain could ever replicate. And somehow, extraordinarily, that is enough to change everything.